Okay, this is Math 10.1. It's all about log. It's the simple one. It's so easy. I'm gonna fly through it. But you need to remember that log base a m plus log base a n can be expressed as log base a m times n. Also, you need to know log base a, I don't know, x to the power of n. When you have a power, it can be taken out as a coefficient. It's the same as n times log base a x. Okay, also log base a m minus log base a n is the same as log base a m over n. Okay, very nice, very easy. Using these rules, we're gonna solve. Okay. The first thing is evaluate the following, enter an integer as your answer. Okay. Also remember, if you have log base a to the power of 18, okay, the bases cancel. Okay. Remember, log base answer power, right? BAP. So if I were to write for you log base 2, I don't know, 8 equals p. Okay, this is the same as saying base, remember, base answer power. So it's the same as saying 2 to the power of p is equal to 8. So obviously, what would p be equal to? P would be equal to 3, right? So remember, log base answer power. That's how it is. So when you see something like this, log base 5, 5 to the power of 18 equals what? Okay, remember, base answer power. Base, so 5, the power is, let's call it x, okay, equals 5 to the power of 18. So obviously, what's x going to be equal to? 18. So in other words, this is why we tell you, if you have something like this, where the base of the log is the same as the base here, they can just cancel and you're going to get 18. Okay? Over here, log base 3, 243. Okay, obviously here we don't really know what to do, but same thing, you need to always try and express it in terms of the base. So 243 is actually, I think it's 3 to the power of 4. No, 3 to the power of 5. So it's going to be log base 3, 3 to the power of 5, right? So you can cancel the 3 with 3, you're going to get 5. Very easy. Question 2, it doesn't even need that much here. Over here, log base 6, 7, log base 6, 7 plus log base 6, 12 is log base 6 what? When we have addition, what do we do with the term under the log? We multiply them. So 7 times 12 is 84. Following the rule, log base a m plus log base a n is equal to log base a m times n. Okay? Log base 5, 7 to the power of 18 equals something log base 5, 7. Okay, so here they're saying, okay, log base 5, 7, and then it's to the power of 18. So what can we do? What can we do about the power? What do we do with the power? See here in the answer, they took out the power. So when you take out the power in a log, when you have log base a m to the power of n, what do you do with the power? You take it out as a coefficient, right? So it's going to become 18 log base 5, 7. Okay, this is the rule. Type, given that, let me erase, and maybe we use the rules. Given that x is greater than 7, okay, log base, please remember, log base, I don't know, ax, okay, this x has to be greater than 0, it's a condition, okay? Given that x is greater than 7, you're going to use this later. It works, remember, for ln, the domain of ln has to be x greater than 0, okay? When we get to ln, we'll talk about it. Okay, given that x is greater than 7, then log base 6x squared minus 49 plus 5 log base 6, 1 over x plus 7 plus 6 log base 6x is equal to this. Okay, let me separate this. Type. So we have over here addition of logs, and they have the same base, right? So we can use our rule over here. When we have the same base and you're adding logs, we multiply. But before you rush and you say, easy peasy, please don't forget there's coefficients here. you can't add them as a phi coefficient. You have to take that coefficient back inside. Okay, let's do it. We're gonna rewrite this as log base 6 x squared minus 49 plus log base 6 1 over x plus 7 to the power of 5. Okay, I took the 5 back in. Remember, coefficients with logs, they're powers. Plus log base 6 x to the power of 6. I took the coefficient in. Okay, now we have addition of logs, so we can rewrite all of this as one big log. So it's going to be log base 6, open up, x squared minus 49 times 1 over x plus 7 to the power of 5 times, well, just x to the power of 6, right? So let's do this. I think this is very, very easy. Everybody should be familiar with this. First of all, this is x plus 7, and this is x squared minus 49. Can't we factor x squared minus 49 to be x minus 7, x plus 7? You know, using the rule a squared minus b squared is equal to a minus b, a plus b. Yeah? So I'm going to rewrite this like this. I'm going to come in here. X minus 7, x plus 7. Okay, this power 5, we're going to take it inside the fraction, up and down. So it's going to be times 1 to the power 5 is just 1, x plus 7 to the power of 5 times x to the power of 6. Okay, we can do some cancelling here. We can cancel x plus 7 with one of the x plus 7s here. So this will become what? 4. Okay, so you're going to be left with x to the power of 6, x minus 7 over x plus 7 to the power of 4. So let's fill in what they're asking us here. The power of x on top will be 6, so k is 6, and the power of x plus 7 down m is 4, as we have here. Okay, very easy. Okay, consider the equation log base 7 x plus 5 equals 2. When is it only defined? Okay, like I told you, the domain of log and ln, the what's inside, what's under it has to be greater than 0. It must be greater than 0. So in this case, x plus 5 must be greater than 0. One of the reasons for this, by the way, is because, just so you can kind of understand, let's say you have log base, I don't know, x, 2 equals, I don't know, 5. Remember, base, answer, power. So this is the same as saying 2 to the power 5 is equal to x. So, okay, we know 2 to the power 5 is 32, so x is obviously 32. But my point is, whatever answer you put here is going to be your power, right? So it's always going to be 2 to the power of whatever you have here, right? Let's say you put a negative number here, negative 1. So it's going to be 2 to the power of negative 1 equals x. So that means x will be equal to 1 over 2. But still, x is still positive. Let's try whatever number, let's say negative 5. It's going to be 2 to the power of negative 5 is equal to x. So x will be 1 over 2 to the power 5, which is 1 over 32. But what's my point? My point is whatever value you input for the power, you're raising a positive value to a power. Even if the power is negative 1 million, you're still gonna get a positive value, but it may be 1 over 0.0000000 something, right? It might be a very small number, but my point is, it might be, it might be a very small number, but my point is, you're gonna get, it's still gonna end up being positive. So whatever you do, you're gonna end up getting a positive value for this x. This is why the domain of log and ln is always positive. Okay, it must always be greater than 0. So anyway, x plus 5 is greater than 0, take the 5 there, x is greater than minus 5. Very easy. What is the solution to the given equation? So they told us here, log base 7, x plus 5 equals 2. So what does this mean? Remember, base, answer, power. So base 7, the power is 2, well, the answer is x plus 5. That means 49 is equal to x plus 5. So what's x equal to? 44. Very easy. I'm taking too much time on this. Question 3. Let's let it load. Okay, very easy. Looks very easy. Log base 4 plus log base 64x plus log base 254 through log base 256x is equal to k over 12 log base 4x, where k is equal to 90. Okay, so this is a stupid question. I don't really like it, but they're just trying to test you on change of base. Okay, so they want you to simplify these 3 logs. And as you can see, these are all powers of 4. Okay. So obviously, you're going to want to, as they told you in the final answer, that they want it in terms of log base 4. So what's nice about log is there's something called the change of base form. If you have log base AB, you want to change it. Maybe مش عاجبك هيدا البase E. You don't want it. It's ugly. You want to write it in terms of a new base C. Okay. you would just rewrite it as log b over log a, but now with base c. So what's nice is log base ab can be written, if you want to change it to a new base c, where c is any number of your liking, okay? It can be written as log b over log a, but with bases c that you chose newly. So an example of this would be مثلا log base, I don't know, 243 would be equal to, let's say I want to change it to a new base, I don't know, 9. Okay, we're gonna rewrite it as log 243 over log 3, but now with our new base 9. You see? Okay, anyway, this is not the one that people usually use. This is change of base. But another one that we also use is this ln b over ln a, right? Which we're going to talk about in the next section. I know I'm getting ahead of myself, but it's because ln is just the same thing as log e. So in this case, well, basically this formula that you guys know, it's the same thing as saying log e, right? So in this case, the base c that they choose for this formula is the number e. Okay. Anyways, this is the formula. You just do log b over log a, and the basis is whatever you want. So over here, we obviously want to manipulate this to be in terms of base 4. So how do we manipulate this? If we want to change the base, what do? We do log x over log 64. Choose your base. Into what do you want? You want the base 4, right? Because we want everything to be in terms of 4. So we're gonna get this. That's nice. Okay, so we're gonna write this on the side. Okay, plus over here we want to also change this in terms of base 4, right? Because we want everything in base 4. So same thing, you want to make it in terms of base 4, log x over log 256, base 4, base 4. Okay, we can do a bit of simplifying here, right? Because log base 4, 64, if you do this on a calculator, I know you can do it in your calculator, you can do it in your head, but if you solve it, you're gonna get that this is 3. Answer. Yeah, it's 3. And you're gonna get that this is 4. Okay, if you do these on a calculator. Why? Because 64 is 4 to the power of 3. So you have log base 4 to the power of 3. And what did I tell you when you have same base? Cancel. And over here, log base 4 to 56. Again, this can be solved on a calculator, no? This part, the simplifying part. This is 4 to the power 4, so this can cancel. And you're going to be left with 3 over here and 4 over here. See? So, moving on, we simplified and we got this. And I think everybody knows how to work with this. And you just do common denominators because you want to add fractions, right? So, I think the common denominator that would work best here is 12. So, let's multiply by 12 over here. So, we're going to make it 12 log base 4x over 12. Plus, over here we're going to multiply by 4 up and down. 4 log base 4x over 12. And here we're going to multiply by 3, 3 log base 4x over 12. So you're going to get 12 plus 4 plus 3, which is 19 log base 4x divided by 12. And they write it like this, k over 12 log base 4x. So 19 over 12 log base 4x. Nice and easy. Okay, so k is 19. Question 4. What is the value of x if log base 10 x squared plus 28x plus 206 equals 1? How do we solve? Remember, base, answer, power. So 10 to the power of 1 is equal to x squared plus 28x plus 206, and 10 to the 1 is just 10. So 10 is equal to x squared plus 28x plus 206. And this is obviously a quadratic, so let's move everything to one side. You're going to get x squared plus 28x plus 196 is equal to 0. You can do this on a calculator, or you can do quadratic formula. I can't factor this in my head. So I think this is a perfect square. It's 14 squared. Hold up. Let me see. 14 squared. 14 times 4. 4 times 4, 6. 1 times 4 plus 1, 5, 0. Yeah, okay. So this is a perfect square, actually, if you want to factor this. So if you factor this, it's going to be x plus 14 squared or other people do x plus 14, x plus 14, I don't care. But you're gonna get the same solution, which is what? X is equal to negative 14. Okay, so the answer here is negative 14. Someone might come and tell me, so Walid, isn't x supposed to be greater than 0 in log? How do you get negative 14 as your answer? I understand, and that's completely fine to ask these questions. But x means the whole thing that's under the log. Here, I'm telling you just the x value here is negative 14. When you add it all up, you're gonna get something that isn't negative. Anyways, if it was like this, log base x, log base ax, and you got x to be negative 14, then this is wrong, because all you have under the log is just x, and if that was negative 14, then it will make it undefined. But here you have a whole equation under it, okay? So it doesn't differ. Question 5. What is the value of a if minus 3 log base 9, 2 plus 3 log base... Okay, kill on log base 9, they want to simplify. Okay, very easy. Like I told you, you need to take the coefficients inside. So it's going to be log base 9, 2 to the power of negative 3, plus log base 9, 5 to the power of 3, plus log base 9, 4 to the power of 2. Okay, so what is this? This is 1 over 8. What is this? This is 1 over 125. Okay, hold up. Okay, no, forget about what I was doing now. We have addition, and they're all the same base. So what do you do when it's the same base and it's addition with the logs? You multiply, right? So we're going to put it all under one log. 2 to the minus 3 times 5 to the power of 3 times 4 squared, right? So it's going to be, you do some calculator, you're going to get 125 times 16 divided by 8. Let me get my calculator. 125 times 16 divided by 8. 250. Okay, so that's the answer for A. Very nice. Okay, do I end it here or will I continue? I'll end it here, and I'll do a separate recording for 10.1.